Welcome back to my YouTube channel. So our topic for today is confidence intervals and the sample size. Okay, so what is an interval of confidence? Okay, so a confidence interval is a range of estimated values which determine how much the uncertainty is with any particular statistic. Margin of errors are being used to add or subtract the mean or the population proportion in order to provide the values of the confidence interval. So this region represents the confidence interval. So this is the lower confidence value and this is the upper confidence value. Okay. Okay, so when we say the margin of error, it determines the difference between the real population value with the results in terms of percentage points. This is also a range between the values of the given confidence interval. So this is used for z-test, while this is used for population proportion. Okay, so here is the first interval. So this is the interval which focuses on population mean with known variance. Okay, so let x bar is the sample mean, the sigma is the population standard deviation, the z wherein the significance level is being based, then however it's being divided by 2 is the z value according to the significant level A, and n is the sample size. So here, this is the margin of error. Okay, so we are going to compute involving this confidence interval. Okay, so we're going to find the confidence interval and its length based on the following. So we have the given standard deviation, we have the given sample mean, and we have the given sample size. So here is our confidence level. But first and foremost, what are we going to do is we're going to find the confidence interval first. Okay, so to get the confidence interval, we need to compute first the margin of error. So this is z alpha over 2, then the standard deviation over the square root of the sample size. Okay, so since our confidence level is 90, so I have provided this table of z distribution, so you will no longer have a hard time looking for this. Okay, so the 90% corresponds to 1.645. Then we're going to substitute the standard deviation, which is 1.20, then the square root of 225. Okay, so what are we going to do first is we're going to find the square root of 225. Okay, so the square root of 225 is, okay, so here is our calculator. We can use this calculator. Okay, so we're going to find the square root of 225. Okay, so here, we have 15 here. Okay, so using our calculator, okay, so we can use our calculator since this is statistics. Okay, so we're going to clear everything first. So what are we going to do is we're going to multiply 1.645 with 1.2, then which is 1.974, then we're going to divide it by 15. So the quotient will be 0.1316. So this is the margin of error. So in order to get the upper bound and the lower bound, okay, to get the upper bound, all we have to do is we're going to add with the sample mean with the margin of error. So adding this, so it will become 7.4316. In order to get the lower bound, we're going to subtract the sample mean with the margin of error. So the difference will be 7.1684. So therefore, the confidence interval states that according to 90%, okay, 7.1684 is the lower bound, while the upper bound is 7.4316. Okay, so in order to get the length, okay, so here are the two ways. Okay, so in order to get the length, okay, so all we have to do is to multiply the margin of error with 2. So it will be yung 2 sa huli, then followed by 3, then it will become 6, then 2. So 0.262 is the length. Okay, so another way is, so this is the first way, and the alternate way is 7.4316 minus 7.1684. So we're going to subtract, it will become 0.2632. So this is the length of the confidence interval, while this is the interval according to confidence level, which is 90% and the given. So this is the confidence interval. Okay, so what if the sample size is less than 30? That's why we use this z value because the sample size here is greater than 30 since 225 is greater than 30. Okay, so here we're going to use a t-distribution instead of c if the sample size is less than 30. So it's just the same way. Okay, so here I have provided the table of values or the table of t-distribution, so you will not be having a hard time here. So our standard deviation is 3, while the sample size is 16, while the mean is 24. Okay, in order to find the t-distribution, okay, so which is t alpha over 2. So in order to get that, okay, so we need to find the degrees of freedom. So the sample size is 16. The degrees of freedom is 15 because 16 minus 1 is equal to 15. So we're going to correspond here. Then our confidence level is 95%. So here, this is the significance level. Okay, so in order to get the significance level, 100 minus 95, which is 5%. So here, so what are we going to do is we're going to locate the 5%, which is here. So this is 1.753. Okay, so this corresponds to this significant level and the 15. Okay, so the alpha over 2 is 0.05. Okay, so what are we going to do here is now we're going to find the margin of error. Okay, so it will become 1.753 times 3, then square root of 16. So we're going to find the square root of 16, which is 4. So now we're going to compute. So I guess we can do it directly. Okay, so which is 5.259 divided by 4. So the quotient will be 1.31475. So before we proceed, let's verify if it's correct. So this is the margin of error. Okay, so what are we going to do here is we are going to find the confidence interval. So the upper confidence is the mean minus plus, plus 1.31475. So the sum will be 25, then 3, 1, 4, 75. Okay, for the lower bound, 24 minus 1.31475. So it will be 5, 2, 5, 8, 6, 23. So, okay, so this will be 23.68525. It's because we subtracted the sample mean with the margin of error. Okay, so according to the confidence level 95%, okay, so the interval will be 23.68525 is less than mu is less than 25.31475. So this is the length of the confidence interval. Okay, so what are we going to do is we're going to find the length. Okay, so in order to find the length, okay, so let's make it simple. We're just going to multiply the margin of error with 2. So it will become 0, then 5, then 9, then 2, then, hmm, then let's say 6, then 2. So we're going to check if it's correct, okay? So 1.31475 times 2, it will become 2,600, 2,006, 2.6295. Okay. So it's 2.6295. Okay. So this is the length of the confidence interval, while this is the confidence interval. Oops, I made a mistake here. So this is not 23.68525. So it should be 22. Okay, so this is 22. Okay, so correction. The lower bound is 22.68525. So based on the interval, the lowest value is 22.68525 and the higher value is 25.31475. So here is the correct interval and here is the length. Okay, for the population proportion, okay, so instead of mean, what are we going to use is the population proportion. Okay, so here, what are we going to do here is, we're going to find the q hat, or let's say 1 minus p hat. So to get this, we're going to subtract 1 with 0.58, which is 0.42. Okay, so here we go again. We're going to find the margin of error. So what are we going to do here is we're going to multiply p hat with 1 minus p hat, then divided by the sample size. Then afterwards, we're going to find the square root. Then we're going to multiply the z value. So to get the z value, we have the confidence level, which is 99%, which is 2.576. Okay, so here, we're going to substitute here. Substitute everything what is given. Okay, so this is 0.58 times 0.42 over 576. Okay, so what are we going to do here is we are going to multiply 0.58 with 0.42. So it will become 0.2436 over 576. Okay, so now we're going to divide what's inside the square root. Okay, so this will be, okay, 2.576. This will be the answer. However, let's try to make things exact. Okay, so what are we going to do here is we are going to find the square root directly. So this is times 0.2, I 0.0, then 206. So we're going to just round it off right away. So the answer will be, it will be 0.0530656. Okay, so what are we going to do is we can round this off, so it will become 0.05 instead. So to get the upper bound, okay, so what are we going to do is 0.58 plus 0.05, it will become 0.63. For the lower bound, it will become 0.58 minus 0.05, it will become 0.53. Okay, so what are we going to do is to state the interval, which, oops, I made a mistake in my handwriting. Okay, so it will become 0.53 is less than p hat is less than 0.63. Okay, so here's the margin of error. Okay, so to get the length, what are we going to do is to multiply 2 with 0.05, which is 0.10. So this is the length of the confidence interval. Okay, so here, what are we going to do here is to find the sample size with a known population proportion. So this time we are looking for the sample size. Okay, so here, what are we going to do is we're going to state the 1 minus p hat, which is 1 minus 0.92, which is 0.08. Okay, then the margin of error is 0.078. So going back to this formula, okay, so shall we rewrite the formula? Okay, so what are we going to do here is we're going to rewrite the formula. Okay, so the z value according to the confidence level is 1.96. So we're going to square the 1.96, then multiply with 0.92 with 0.08, then divided by the square of the margin of error. Okay, so we're going to use the concept of PEMDAS first, which is 1.96, then square, so it will become 3.8416 times 0.92 times 0.08. Then we're going to find the square of 0.078. It will become 0.006084. To be more accurate, we can multiply and divide it directly. Okay, so it will become it will become 3.8416 times 0.92 times 0.08, then divided by, but before that, let me write first, 282.74.176 divided by 0.006084. So we're going to divide it with this. So it will become 46.47. Okay, usually we round off. However, since this is greater than 46 numerically, okay, so we're going to round up to 47. So the sample size will become 47. Okay, so here, so if the population proportion is unknown, we use 0.25. Why? Because this is the product of p hat, which is 0.50, then our q hat, which is 0.50. So we do not know what the population proportion is. So that's why we use 0.5. So we guess it that it is 0.5 as the p hat, then the q hat. Then we multiply it together, which will be 0.25. Okay, so here, so the given is the margin of error and the z-value according to the confidence level, which is 99%. Okay, to get the z-value, okay, so we're going to find the z-value that corresponds to this confidence level, which is 2.576. Okay, so here, to get the sample size, we're going to square the z-value with 0.25, then divide it with the square of the margin of error. Okay, so we're going to do the same thing as we did in the previous example. Okay, so it will become 6.635776 times 0.25 over 0.124 times 0.124, which is 0.015376. Okay, so we're going to check if it's correct. Okay, so what are we going to do is, okay, so multiplying, it will become 1.658944 divided by 0.015376. So it will become 107.89. So now we're going to round up. It will become 108. So the sample size is 108. Okay, so do not forget to subscribe my YouTube channel and hit the notification bell. But here are the references where you can use as the learning materials. Okay, so we are going to choose at least one calculator. So here, so this is the confidence interval calculator. So how many in sample? Okay, so what are we going to do is we're going to try finding the confidence interval using this calculator. Okay, so how many in sample? So let's say this is 225. So I'm going to type this 225. Then the sample mean is 7.30. Then the confidence level is 90. Then the standard deviation is 1.20. Okay, so here is the confidence interval. So the confidence interval has been given for you. Okay, so how about here for, let's say, the sample size is less than 30. So we can, I guess we can use this. Okay, so this is how many in sample, which is, let's say, 16. Then the sample mean is 24. Then the standard deviation is 33. The confidence level is 9. So here, the margin of error is 1.47 here, but this is the rounded off kasi. Rounded off kasi to, kaya nag-iba ang value. So For the population proportion, okay, so we can click this calculator. Okay, so okay, for the population proportion, okay, so since we do not have the given number of favorable cases, but instead we have the given proportion, so this is 0.92, the confidence level is 95, then the sample size is, okay, oops, I guess I typed the wrong given. So the confidence level is 99 pala. Then the population proportion is 0.58 and the sample size is 576. Okay, so we're going to calculate. Okay, so here is the population proportion, the confidence interval. Okay, so there you go. So thank you guys. Have a great day and stay safe. God bless. Happy learning.